What we're going to do here is find the domain and range of a couple simple functions. And when the functions get more complicated, we're only going to do the domain because the range will get very complicated and probably just not worth it. Meanwhile, let's start with just a couple easy functions. Let's start out with f of x equals something like 1 over x minus 2. Now the two principles we're supposed to use when finding domain are make sure that the insides of square roots are always positive. There's no square roots to worry about, so we don't have to worry about it. And make sure we eliminate any numbers that make bottoms of fractions 0. Well, I see here I have to automatically eliminate x equals 2. So I'm going to walk over here, and I'm going to eliminate x equals 2 from being in the domain, and pretty much that's it, right? We can plug in every other number. Now to find the range, it's more complicated, because what we have to do is remembering that we're setting our function equal to y, and then we're supposed to switch x and y and then solve for y. Okay, so I'm going to write down y, 1 over y minus 2 equals x. Let's see here, what can I do? I can cross multiply, so I get 1 equals x times y minus 2, like this. I'm supposed to, in order to find the range, now solve for y. So I'm going to divide both sides by x. I'm going to get 1 over x equals y minus 2. And then I'm going to add 2 to both sides. Like that. Now, what am I supposed to do? In order to find the range, you switch the x's and y's, you solve for y, and then you find the domain of this new function. Well, I can't plug in x equals 0 into the new function, right? So in this switched x and y land, x can't be 0. That's going to tell us in the original range that y can't be 0. Now that's actually a complicated thing. That says no matter what numbers I plug into this function, I can never get 0, and I can get every other possible y value. I mean, it says a lot. We had to do a lot of work to get there, but it does say a lot. Meanwhile, let's look at another example. How about something like g of x equals the square root of 4 minus x, like this. In order to find the domain, again, I have our two principles. Now, by the way, once we hit exponential functions and log functions and trig functions, it's going to be harder to find domain. But until then, all we have to do is make sure bottoms of fractions are never 0. Well, there's not even a fraction. I don't have to worry about that. And make sure that insides of square roots are always positive. So what I'm going to do is just over here, I'm going to write down that 4 minus x has to be bigger than or equal to 0. I'm trying to solve for x, so I'm going to write down that 4 has to be bigger than or equal to x. And I'm going to write this so it feels better. I'm just going to write down that x is less than or equal to 4. I think that's perfectly fine. To find the range, we really do have to worry about it. Because and again, it's harder. The first thing I'm going to notice is that y is a square root. Now, that automatically tells me right at the beginning, and this is something we should always look at, is that the only y values I'm going to be able to get are bigger than or equal to 0, no matter what my algebra says later. Let's look at the algebra and just see what happens. I'm supposed to switch x and y, so I'm going to get x equals the square root of 4 minus y, like that. I'm supposed to solve for y, so I'm going to get x squared equals 4 minus y. Now solving for y, I'll put the y over here, I'll put the x squared over here. So I get 4 minus x squared, something like that. And I'm supposed to look at the new domain of this function. Well, here x can be anything. Right? X can be anything. Woohoo! Unfortunately, that should tell me in the original function that y can be anything, but we had this weird thing at the beginning that said y had to be bigger than or equal to 0. That happens almost every time we see a square root, and so the algebra said that y eventually could be anything, but the original observation we said at the beginning that y could only be bigger than or equal to 0, that is going to give us a range of y being bigger than or equal to 0. Now when we start graphing those functions, that'll be a lot more obvious. I think that's the last range we're going to find, and you can see exactly why. You actually have to think pretty hard almost every time you do it. Meanwhile, let's look at a couple more complicated, or at least different, domains. Okay, how about we have a function something like this. How about h of x equals something like x over x minus 1 times x plus 2, like that. Now our general principles for domain, not going to worry about range right now, say make sure insides of square roots are always positive, well there's no square root there at all, and eliminate all x values that make the bottom 0. So if I'm going to worry about the domain, I just need to eliminate all x values that make the bottom 0. So I'm just going to eliminate 1 and negative 2, and the domain can be anything else. That sounds pretty simple. The graph will wind up being pretty complicated. But we have a domain that just has all real numbers except maybe a problem at 1 and at minus 2. That's that. All right, now let's look at a combination function. This is going to be our last one that we look at. We'll call this one L of x. And how about something like, how about 1 over x plus the square root of 3 minus x. Yeah, that's it. Now, in order to find domains, what we're supposed to do is make sure that insides of square roots are always positive. So I'm going to do that first. I'm going to take the inside of the square root. I'm going to make sure it's positive. So I get something like 3 is bigger. 3 is bigger than x. I'll write this so it feels more comfortable. I'll say x is less than or equal to 3. That sounds like it's the whole domain. But wait, I'm also supposed to make sure that bottoms of fractions aren't 0. So I also have to eliminate x equals 0. So making sure that the inside of the square root was positive, I had to make sure that x is less than or equal to 3. Also, x could not be equal to 0 because it made the bottom of that fraction 0. So there's our new domain. I think this is as complicated as we're going to do for the easy ones. In the next video, you're going to see us do a bit harder one, but then you have to actually be able to solve rational function inequalities. That's something you did do in college algebra. I have a nice video for you to watch. Meanwhile, I will use those principles in doing the next problem.